Hello everyone, welcome to my YouTube channel. I'm Kaushik once again, and today we will learn one very interesting thing, that is matrix representation of linear regression model. By the time we covered a lot of things, especially the metrics and the vectors, and using those we can represent the linear regression model. So let's consider that we have some data sets. If you are already familiar with the linear regressions model, and if you are following my channel, probably kind of you can understand this is the Boston data sets. And these are all kind of different features or predictors. And this is my target variables. All the values here, I'm taking a continuous variable. Some of them are discrete, doesn't matter. Main thing is these are all features, so these are basically my x1 x2 up to xp. I'm considering I have p predictors or p features, and then I'm considering that I have the observation till n. Okay, so interesting thing is, if you think about this data point of view, like only the pricing data, okay, only the price data, okay, this looks like a vector. It's a column vector. So what we can say, that we have capital Y. So let me um, write down. So this is little difficult to do capital Y and all those things. So what I will do, I will just do double line, and when I'm saying double line, it's a vector. It's mean it's a vector. So I can represent this part actually by this, that y1, y2. Actually, give me 1 minute. Let me show in a little bit different way. So what does it mean? This vector, actually, if you just write it in this format, so it will be y1 to yn, right? Because we have n number of outputs and number of, that's why we have y1 to yn. But we can do a transpose operation, because now we know what is the transpose operation. So the same thing, instead of writing like this, what we can do, we can write this like this, that y1 to yn and transpose, which mean it's representing this vector. So this part we can represent like this. And a lot of people say a lot of things. This y are responsible variables, y is the target, y is our final predictors for each observations, like this. And now if you consider this, each of this features or x components, they are also individually a column vectors. So that's mean we can say x1, and again double line mean it's a vector. Remember this thing. So this is again x1 to xn1. This is one vector. And similarly x2, this is again a vector, which can be written as x1 2 to xn2, like this. We can write till xp, because we have p predictors or p features, if you are familiar with the features terminology. So then we can write 1p to xnp, and all these are actually the vectors. Okay, so that's the way we can. So this is basically my representation of the response, or we can say target variables, whatever way you can say. And these are this x1, x2, these vectors are basically my predictors. Predictors. Okay, up to this, I think it should be um, okay, right? Predictors or features, whatever. Now we will collect all these predictors into a matrix. So what does it mean? That we are creating one big matrix, because now we can consider this one as a big matrix which has 1 comma x1, again double line means a vector, x2, this is a collection of this vectors where 1 is actually again the representation in the transpose format. And why we are doing this thing? Because when we do the linear regression problem, normally if you just do a simple math, simple one, right, mx plus c, you're very familiar with this kind of equation. So you have intercept part actually. So for that intercept part we have this 1, and so this is the representation of this big portion actually. Okay, so this part we are representing like this, and this y part is getting represented like this. So now we have x and y. Now what we need to do, we have to find out the parameters, because we know that we will have p number of parameters, right? So let's consider we have a vector beta that is actually having all these parameters, beta 0 to beta, can anyone tell me what will be? Is it a n or is it a p? It will be p, because we have p predictors. So we have and the transpose. Okay, so and be the vector of parameter. So this is basically the that parameter representation. So this is basically the vector of parameters. Okay, I think up to this it is clear, no doubt on this one. And then finally we have one more component. Like if you remember, there will be always a error component. So epsilon is that error component, and that epsilon component can be treated as epsilon 1 to epsilon n, because that is for each observation, and then the transpose be a vector of error term. So this is basically vector of error terms. So let's deep dive little bit more. So now mathematically, if you have to write the equation of the first observation, so if you just try to write the equation of the first observation, okay, what will be that? That will be nothing but y I beta 0 plus beta 1 xi 1 plus x I p plus epsilon I for all I from 1 to n. So for each of the observation, this equation will be like this. So that's mean for the first equation it will be like this: beta 0 plus beta 1 x11 plus x1p plus epsilon 1. Okay, so clear. So if we have to write each observation, that's mean what will happen, you will have to write n number of observations, so it's very difficult. So that's why we will write the model not in this format. One format is this is the way we can write it, okay, that okay, this is the way we can write it. But how we can write these things into the matrix representation so that will be more compact, okay. So first thing is, let's understand that we have the y component, which is y1 to yn, because we have y this part, which is equal to nothing but our matrix of 1 1 1 to n, and x11 to x1n, and x1p to xnp, and we have another beta vector which is beta 0 to beta p vector, beta p, and plus we have the epsilon, which is from 1 to epsilon n, okay. Okay, so cool. So that's mean what we can write, that this is nothing but that this is my y vector equal to, this is my x matrix, which is nothing but the collection of the individual vectors, and then the beta vector plus epsilon vector. So this is the way, this is the simple way we can represent the linear equation, linear regression model using the matrix, okay. So this is very, very important, because later when we will do the higher study, this notation is very, very important to understand, because a lot of time in the class the professor will say everything in this format, and if you are not following how it is exactly happening like this way, then it will be difficult to follow the class. So that's why it's very important. Another thing, let's quickly check one more thing, that always remember that the dimensionality is very important. So y, let me write it here one more time. So basically y is my vector, x is a matrix, b is a vector, epsilon is a vector, okay. So y is basically nothing but n into one dimension matrix, and x, if you check that, x is basically, what is the dimension? Can anyone tell me what is the dimension for x? X is basically, if you just put all these values here and plus 1, so that's mean x is, let's think from this one, how many rows are there, so that's mean it will be n dimension, but predictors is basically p plus 1, that is very important, okay. So x basically n into p plus 1, okay. What about the beta? Beta, if you think, check the result, it's from 0 to p, so that's mean this is actually p plus 1 into 1 vector, and that's the reason this multiplication is working, because you know from the matrix multiplications rule point of view that this dimensions should match with this dimension, otherwise this multiplication will not work. And finally, after this multiplication, what will happen, we'll get n into 1 dimension vector, plus we have epsilon which has 1 to n, so we can say this is n plus n into 1 vector. So if you just add it, you'll finally get n into 1 vector. So that's why this is the representation of linear regression model in a matrix format, and it's very important to understand this concept. I know this is more theoretical thing I'm talking about. Again, I will go back to the actual coding and actual programming, but this is the things, if you understand, you will understand why matrix, why we are reading the matrix from the engineering perspective, from the data science perspective, because a lot of time these representations will be discussed in a class, and this is the representation of the linear regression model, which is y equal to x beta plus epsilon, where y is the vector, b is a vector, x is a matrix, and e is a epsilon is a vector, and all these vectors we have described here. Hope you like it. If you like it, just give me a thumbs up or subscribe my channel. Have a nice day. See you in the next video.